Uh, Today I want to explain the mechanics of solving equation of this type: a sine x plus b cos x, where a and b are constant real numbers and are not zero. Okay, so for example, so for 0 less than or equal to x, less than or equal to 2 pi, solve equation sine x plus cos x equals 0. That means the a value is 1, b value is 1. Okay? So we're going to proceed as usual. Just going to write the equation as is, sine x plus cos x equals 0. Dividing both sides by cos x gives me sine x plus cos x equals 0 over cos x. So over cos x and over cos x. And of course, cos x cannot be 0. So we get sine x over cos x, which is tangent x, plus cos x over cos x is 1, equals 0 divided by cos x is 0. Subtracting 1 from both sides gives me tangent x equals -1. So now the next step of solving this simple trig equation is to identify where the terminal arms are in the quadrant. So tangent negative, so the terminal arms are in quadrant 1 and quadrant 2 and quadrant 4, and the reference angles are here and here, and the reference angle is given by tangent inverse of the absolute value of the constant here. So that is tangent inverse 1, which is pi over 4. So alpha is pi over 4. And we know that we don't have to adjust the domain because the argument, the angle argument in the equation is the same as the angle argument in the domain. So all we need is to figure out the solution. So from 0 to 2 pi inclusive, positive angle, we go counterclockwise. So that's 1 revolution. And as we can see, as we sweep the angles across 1 revolution, each terminal arm gives us 1 solution. So x1 equals pi minus alpha, which is pi minus pi over 4, which is 3 pi over 4. And the second solution, x2, it's 2 pi take away alpha, or 2 pi take away pi over 4, which is 7 pi over 4. So all of these is predicated upon the fact that cosine x cannot equal to 0. So is this an assumption that is made without any basis? So now let's do a little conclusion. Thus the solution are x equals 3 pi over 4 and 7 pi over 4. Okay, so if we go to a graphical solution, we can see that the point of intersection between y equals sine x plus cos x and y equals 0 is between 0 and 2 pi, are 3 pi over 4 and 7 pi over 4. Okay, so our assumption that cosine x cannot be 0 is correct. Okay, so but this doesn't mean that cosine x is never ever 0. It's just as cosine x equals 0 is not a solution to this equation. Okay, so now let's take a look of an alternate way of solving this equation. So the same equation here, sine x plus cos x equals 0. Okay, we can common factor out cosine x, and the equation is going to be cosine x times sine x over cosine x plus cosine x divided by cosine x, which is 1, equals 0. So this is what the equation has become. So, and we know that if we can express an equation as a product and then 0 on the other side, either one of them is 0 or both of them are 0. But in this case, cosine x cannot be 0, because if cosine x is 0, we have the other factor, we have sine x divided by 0. So it is fair, it's logical to say that if we have written it in this fashion, cosine x cannot be 0. Okay, so since cosine x cannot be 0, the other factor, which is sine x over cos x plus 1, must equal 0. So we can rearrange this equation. So since sine x over cos x is tangent x, the equation becomes tangent x plus 1 equals 0. Subtracting 1 from both sides gives us tangent x equals -1, which is exactly the same as the equation that we obtained using the first method. And then you would just proceed to solve for solve this equation to obtain the x value of 3 pi over 4 and 7 pi over 4 as the solution to the original equation. Okay. Another analogy or another example is consider the equation. So consider the equation. So now I just want to explain further that why this factor, why not both factors have to be 0 if we express this equation, an equation in effective form, one side of the equal sign is 0. Consider this equation, x minus 1 equals 0. Okay, it's a very simple equation, and we know from experience that if we add 1 to both sides, we obtain the value of x, or the solution to this equation, which is 1. As an alternate, I can also common factor out x from both x and -1 to give me x times 1 minus 1 over x equals 0. So we have now written this equation in product form on one side and 0 on the other side. So obviously, because this is the same equation, the solution of the equation is still x equals 1. And obviously we can see that x cannot equal 0. Because if x equals 0, we get a 1 divided by 0. Since x cannot equal 0, 1 minus 1 over x must equal 0. Subtracting adding 1 over x from both sides gives us 1 equals 1 over x. Multiplying x on both sides gives us an x value of 1. Okay, so the fact that we can rewrite this equation in its factored form and that one of the factors is not 0 is a valid way of solving this equation. And of course, we don't need to, in the case of a sine x plus b cos x equals 0, because we can straight away divide the equation throughout by cosine x, because cosine x equals 0 is not part of the solution.